Hello everyone, this is Basileus, and this is the fifth episode of our series on how photogrammetry affected gaming after Battlefield 1 and how it ties to today's games, which are way more demanding but not as equally visually impressive. So, in the last episode, we talked about Battlefield 5 as a turning point. The moment where DICE, and really the entire industry, started moving away from static, carefully controlled environments toward worlds that react dynamically to everything happening inside them. And on paper, that sounds like an obvious improvement. A battlefield where lighting reacts to explosions, buildings collapse in real time, and weather shifts dynamically should feel more immersive, more realistic, and more advanced at the end of the day. But once you start looking closely at how these systems actually work, something interesting happens. The same features that make modern games more dynamic also introduce the very problems that make them harder to run and sometimes even harder to read. Now, for instance, let's go back for a moment to something we mentioned earlier, visibility in Battlefield 5. We talked about that in our previous episode. A lot of players, especially around launch, felt that enemies were harder to see than in Battlefield 1, particularly in cluttered environments or under certain lighting conditions. At first glance, that seems like a gameplay issue. But it is actually a rendering issue, because what players were reacting to wasn't too much detail. It was a world where lighting, materials, and environmental conditions were constantly shifting in ways that made visual clarity less predictable. And that's our starting point. When we say dynamic lighting, it sounds simple, but it actually involves a fundamental change in how games are rendered. In a system like Battlefield 1, most lighting is baked ahead of time, which means the engine already knows how light behaves in every part of the map. But in a dynamic system, that certainty disappears. Light has to be recalculated constantly. Every explosion, every destroyed wall, every change in the environment potentially alters how light interacts with the world. And that means the engine is solving a much harder problem. Not once, but literally in every single frame. Now, if we go back and compare this to Battlefield 1, the difference becomes very clear. In Battlefield 1, lighting is stable, which means that when you look at the surface, it behaves consistently over time. Shadows don't shift unpredictably. Indirect light doesn't fluctuate. Materials respond the same way every time you see them. That consistency is a huge part of why the game feels so readable. In Battlefield 5, that consistency starts to break down. Not because the technology is worse, but because it's doing more. Lighting is reacting, updating, adapting. And in doing so, it introduces variation that didn't exist before. And this is where we hit the core issue that sits underneath almost everything we've been talking about: noise. Real-time global illumination, the kind of lighting modern engines use, is inherently noisy. The engine is trying to approximate how light bounces around a scene, but it cannot calculate everything perfectly in real time, so it relies on approximations, sampling, and estimation. The raw result of that process is not clean. It's unstable. It flickers. It breaks apart under motion. And that means the engine needs a way to fix it. This is exactly what we saw in AMD's recent presentation of FSR Redstone. They showed raw upscaled frames before the AI model cleaned them up. And what you see in those frames is not a finished image, but something much closer to a work in progress. Noisy, fragmented, and lacking the coherence you expect from a final frame. And that's important because it reveals something that isn't always obvious when you're just playing a game. Modern rendering doesn't produce a clean image first and then display it. It produces an approximation and then spends additional steps trying to stabilize and reconstruct that approximation into something that looks correct. So when you're looking at a modern frame, you're not just seeing rendering, you're seeing correction layered on top of it. At this point, reconstruction techniques like temporal accumulation, like filtering, like upscaling, stop being optional optimizations and become essential parts of the pipeline. Without them, the image would simply fall apart. But those techniques introduce their own trade-offs. They can soften detail. They can introduce ghosting. They can reduce clarity in motion. And this brings us back once again to the player experience. Because when players say that enemies are harder to see in a game like Battlefield 5, what they're often reacting to isn't just art direction or map design. They're reacting to a combination of higher visual density, dynamic lighting variation, and reconstruction techniques smoothing the image, all working together in ways that reduce clarity compared to something like Battlefield 1. And this is where the core trade-off that defines modern graphics lies. Dynamic lighting allows for worlds that feel alive, that feel reactive, and that are unpredictable. But that same flexibility introduces instability. It introduces noise. And it introduces performance cost, which then have to be compensated for using increasingly complex reconstruction systems. In other words, you gain realism in one dimension, interaction, and lose it in another, consistency. So you gain realism in terms of interaction and lose it in terms of consistency. So dynamic lighting didn't just improve graphics, it fundamentally changed how games are built. it turned rendering from a problem of precision into a problem of approximation and into a problem of correction. And once you understand that shift, the rest of modern graphics technology starts to make a lot more sense. Because next time, we're going to take the next step in that evolution, and ask a bigger question. If all of this complexity is required, why did engines like Unreal 5 fully commit to it with systems like Lumen, for example? I hope you enjoyed this one. I am Basileus. If you did enjoy it, please consider subscribing and liking. It helps immensely. If you didn't, I'm open always to suggestions. And I'll see you in the next one. Bye!